Hi guys, and thank you for taking interest in our app 3D Polate. This app demonstrates how complex interpolation algorithms can be made available for everyone through a web browser. But it doesn't only guess the values in between your existing dataset, it also tells you which method had the highest and lowest error. Hopefully this workflow, where you not only enrich a dataset with new knowledge, but also provide some insights on the strengths of the estimates, can be of use to some of you. Okay, let's start it. There is actually a tutorial, but for the sake of time, I will not show that now. I'll just go directly to the app. But please try this out by yourself. Okay, so first you're brought to the welcome site. Here you can play with the logo in 3D. But as it says, you need to go to load data to get started. So when you go to load data, the test dataset is already provided from the GStat package. So this is actually a polluted riverbank in the Netherlands, I think. So you can see this is the zinc concentrations, and it's quite high actually. So this is quite polluted. And but we also see that we do not know the concentration at every point in this area of interest. So we can do some interpolations to look at the estimates of values in between our sampling points. So you can also upload your own datasets, but I'll not show you that now for the sake of time. So then we provide you with this panel where you can run 3 different methods to interpolate. So the first ones are deterministic interpolations, and then it differs between inward distance weighting and nearest neighbor. I won't go into details about the method behind those, but I think I'll just show you that you can very easily provide tips for your end users in Shiny. I think this is a very nice feature, which is very easy to set up. And this is also quite nice if you look at the geostatistical method here provided with the Krieging. This is quite complex, so it just guesses, makes a best guess for you which values to use for the model, and then you can make some model assumptions. You can also look at how well your model fits your dataset before you run the model. This is a way to validate your model. And then it's very easy and very snappy to just change between different models. And here again, you can also provide some more tips to the end users with some nice graphics to inform them how to use your app. So I've already actually ran these interpolations, and here you can see the errors for each method. This means that we have taken out one sampling point at a time from the dataset, and then we use the remaining data points to guess the values. So then we have the difference between the guess, the observed and the predicted value for each point. Then we sum the errors for all of the data points within the dataset, and then we get the error for each method. And we do that for every method we applied for this dataset. Then we compare it to the baseline, which is just a very simple interpolation, the simplest of them all, which is just the average of every data point. So you see that at least for Krieging, you have a far lower error than you have if you just do the stupid baseline case. This is a very nice way to show the end user that you actually found some correlation. You're not just playing with the dice here. Then you can go forward to view the results in a 3D grid. Then you have to choose the method. So now we're looking at the geostatistical Krieging results. If you remember from the low data, you remember there were some hotspots, and you can see the resemblance of that within the 3D grid where we applied our model and where we provide estimates. Here you can see the values. You can also go into the details if you like, and you can also export this dataset if you want to do further analysis. And you can also look a bit more into the details in between the different methods on how they differ for the estimates provided. At the end of this app, we also added some more info on how we use Shiny at the Norwegian Geotechnical Institute, which is my employer. So So we are an independent international center for research and consulting within the engineering geosciences. And we use Shiny both in our R&D projects where we put up portals to interact with our external partners, but we also have some production grade applications which we are running in Kubernetes to serve internal needs. So these are production grade where we do a proper software production pipeline, and which I think is really nice that we get to put this up to do production grade Shiny apps. In addition, we have listed some of the packages we use. So please visit the GStat GitHub page, a really nice package. And I also must mention that we visited the GitHub for Radar, the Radar app, which we both looked at and borrowed some code from. It's developed by Christian Lutz. Thank you for sharing. And I, of course, have to mention that we are hiring, so please follow this link if you would like to join our team here in Norway. And in addition, if you want to learn more, we did a USR presentation about our Shiny apps, so you can follow this link to learn more about that. Then I'll say thank you for watching and enjoy your Appstorm conference.